Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2021 paper 2. And today we will be solving question number 9 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists. So without any further delay, let us start answering question number 9. The maximum mark is 50. The question says the height of water in meters in Dungeness Harbor. I'm sorry if I'm not pronouncing it correctly. Is modeled by the function h of t equal to a times sine of b times t minus c plus t, where t is the number of hours after midnight and A, B, C, D are constants where A is greater than 0, B is greater than 0, C is greater than 0, and also from the graph we are seeing that the principal axis is not the t-axis, rather it has moved up, it has got translated above upwards, so D should also be greater than 0. And this is the graph given, and it is saying the first high tide occurs at 4:30 and the next high tide occurs 12 hours later. Throughout the day, the height of water fluctuates between 2.2 meters and 6.8 meters. And these are the first, there are many several subparts for this question. I have just written the first 4 subparts over here. The subpart A is show that b equal to pi over 6 and it contains just a single mark. Okay, so this statement says the first high tide occurs at 4:30 and the next high tide occurs 12 hours later. So the periodicity is 12 hours. Therefore, let us start our answer from this point. And it is the periodicity is 12 hours, so this should be equal to 2 pi over b. So this gives us the b value as 2 pi over 12, which is equal to pi over 6. Okay, so shown. Okay, let me just write it a better way so that it is readable. Okay, fine, shown. And so part B, find A, this A. So A is the amplitude and we are seeing the height of water fluctuates between 2.2 meters and 6.8 meters. So A should be equal to 6.8 minus 2.2 divided by 2, which is equal to 4.6. You may use your calculator, but it is a very trivial subtraction, so you can do it. 6 minus 2 is 4 and 8 minus 2 is 6. So, and of course, you should be doing the 8 minus 2 first of all. Okay, so this is 2.3. So the A value is 2.3. A is 2.3 and B was pi by 6. Coming to D. Okay, coming to D. Find D. Subpart is C. Find D. So D is the principal axis. It is also the vertical translation. So D will be equal to 6.8 plus 2.2 over 2, which is equal to 8 and 2 will be giving you 10. So carried 1. 6 plus 2 is 8 plus 1, 9. 9.0 over 2, which is 4.5. Okay. So D is equal to 4.5. Now coming to subpart D. Find the smallest value of C. C is the horizontal translation. Find for that, what we do usually, we take the maximum value of the height, which is in our case 6.8. So I am writing 6.8 equal to, in place of h of t, I am writing 6.8. In place of a, I will be writing 2.3. And then sine, in place of b, it is pi over 6. In place of t, when is the 6.8 meters height occurring? Height of water, at 4:30 a.m. So it is 4.5 hours after midnight, and 4.5 hours is 9 over 2. So it is 9 over 2 minus C plus D plus 4.5. Okay. So 6 minus 8 minus 4.5 divided by 2.3 is equal to sine pi by 6 and 9 over 2 minus C. We have to get the C value, and first of all, let us get this value. So 6.8 minus 4.5 divided by 2.3. 1. This is equal to 1. Okay. So pi over 6 times 9 over 2 minus C should be equal to sine inverse of 1, which is equal to pi over 2. If we cancel these two pi's, we see if we multiply both sides by 6, I don't think I'm having sufficient space to write below this line. Let me write it over here. Okay. So I have just cancelled the pi's from both the sides. That is, I have just divided the entire equation by pi. Okay. And next, what I am doing, I am multiplying the entire equation by 6. So it is 9 over 2 minus C equal to 6 over 2, which is equal to 3. Okay. And then C is equal to 9 over 2 minus 3, which is equal to 9 over 2 minus 6 over 2, or C is equal to 3 over 2, which you may write in decimal form. So C value is equal to 1.5. So this is the smallest value of C, because 1, I can write 1 as sine pi by 2. Okay. I can write 1 as sine pi by 2 plus 2 pi. So you will be getting different values of C. If I take sine pi by 2 plus 2 pi, okay, then it is pi by 2 plus 2 pi is 4 pi by 2. That is 5 pi by 2. So sine 5 pi by 2 is also equal to 1. And if I take that value, 5 pi by 2 instead of pi by 2, I'll be getting some higher value of c. But they have asked for the smallest value of c, so we have taken the pi by 2, not 5 pi by 2 or the other high values, because it is an unending wave. The sine wave is an unending wave, so you will be getting the amplitude of 1 at regular intervals after every 2 pi. Okay, so this is the smallest value of c, and we have answered the first four subparts of this question number 9. Let me bring the next subpart. Subpart E. Find the height of the water at 12. It may be 12 noon. Let us take 12 noon. Okay. So, subpart E. The equation is this one. H of t is A times sine of B times t minus c plus t. So, let me just substitute the values. We had found these values in our first four subparts. So, h of t is equal to 2.3 times sine of pi over 6 times t minus 1.5 plus 4.5. Okay. And now it is saying 12. So I'm taking it is 12 hours after midnight. Okay. So this will be h of 12. This is equal to, and it is just containing 2 marks. 2.3 times sine of pi over 6 times 12 minus 1.5 plus 4.5. Okay. And this is paper 2. Obviously, we can use the GDC calculator. We will be using the calculator. It is 2.3 times sine of pi over 6 times t is 12 minus c was 1.5 and another bracket plus 4.5. D is 4.5. Enter. 2.87 meters. The unit was in meters, so 2.87 meters up to 3 significant figures. Okay. Okay. Now coming to subpart F. Determine the number of hours over a 24-hour period for which the tide is higher than 5 meters. It is containing 3 marks. Okay. Actually, the height will be more than 5 meters. So h of t will be more than 5. So the inequality will be 2.3 and sine pi over 6 t minus 1.5 plus 4.5. This should be greater than 5. This is the inequality. And we have to solve this. So let us use the graph. Okay, I'll be using the graph. It is 2.3 times sine of pi over 6 over 6 times this. I'll be writing in place of t, I'll be writing x. X minus c was 1.5 plus 4.5. Okay, enter. Fair enough. Let me just bring it down. It was the highest is 6.67. So let me just bring it down. Let me change the settings, window settings. Okay, it can be the x-axis can the okay the x min and the y min, x min can be -1. I can take that as -1. Y x max can stay, and y min I am changing this to say 1. Okay, and this to say 7.5. Okay, and over they have said over a 24 hours period. Okay, okay, so I have to change the x settings as well. Fine. Over a 24-hour period, so this should be at least 25. Let me take it as 25. Okay, fine. And this should be greater than, the height should be greater than 5 meters. So let me just draw the y equals 5 line. This is the y equals 5 line. So we are seeing that this part of the graph is above the y equals 5 line, and also this part of the graph is y equals 5 line. Of course, I have taken up to 25, but you see, they have asked up to 24. So it is well before the 24. So I don't have to get the 24 marking, although I have taken the graph up to 25, but I am pretty sure that this is not going exceeding 24. And also I'll be getting the intersection points. So for that, analyze graph, the intersection, this one and this one. Fine. Another intersection is this and this. This and this. And this and this. So you see, the last one is t equal to 19.0815. So it is before, definitely before 24. Okay. So we are seeing that the height of water is above 5 meters when the time is between 1.91853 and 7.08147, and also between 13.9185 and 19.0815 hours, of course. Okay, hours after midnight. So let us just copy them. Okay, if you want, if you have time, you can sketch the graph, or else you may just write using GTC graphs. The height of water is more than 5 meters, between t equal to 1.91853, 1.91853, and t equal to 7.08147. 7.08147, and also between t equal to 13.9185, 13.9185, and t equal to 19.0815. 19.0815. Okay. So, therefore, total number of hours is equal to 7.08147 minus 1.91853 plus 19.0815 minus 13.9185, which is equal to, let me go to the calculator again. I have to write these numbers. 7.08147. 7.08147 minus, it is 1.91853. 1.91853. 1.91853. Let me put bracket over here. Plus 19.0815. I could have doubled this part. This interval is by the graph also and by the symmetry as well. You can very well understand that these two portions are having equal number of hours. So you can just get this part and multiply by 2. But anyway, since I have written all these four numbers, I'm just adding them. 19.0815, 19.0815 minus 13.9185. 13.9185. Okay. Enter. 10.3 hours up to 3 significant figures. Okay. 10.3 hours up to 3 significant figures. Okay. So we have completed up to subpart F, but we are having one more subpart remaining. So let me bring that subpart. Subpart G. A fisherman notes that the water height at nearby Folkestone Harbour follows the same sinusoidal pattern as that of Dungeness Harbour. Sorry, previously I had pronounced it wrongly. There's a single N, so it should be, I think, Dungeness Harbour, with the exception that high tides and low tides occur 50 minutes earlier than at Dungeness. And subpart G says find a suitable equation that may be used to model the tidal height of water at the Folkestone Harbour, and this contains 2 marks. And this was the equation that we had found previously for the Dungeness Harbour, and it was said that the first high tide occurs at 4:30. This is for the Dungeness. 4:30, and the next high tide occurs 12 hours later, because everything is the same, follows the same sinusoidal pattern. So the water height will be fluctuating between 2.2 meters and 6.8 meters, and the sinusoidal wave will be having the periodicity of 12. Since it is having the periodicity of 12, the B value will be the same. Since the water height is fluctuating between 2.2 meters and 6.8 meters, the A value and the D value, they will be the same. The only thing that will be differing is the C value. Why should it differ? Because the high tides and the low tides are occurring 50 minutes earlier. That means the graph is getting horizontally translated. Okay, so the horizontal translation is shown by the C value, by the letter C, that part. So C value will be getting changed. We have to get the value of C. So for that, let me take the, previously also we had taken the highest water height. So even now I am taking the highest water height, that is 6.8. I'm writing this for in place of h of t. So this is equal to 2.3 times sine of pi over 6 and t. Now coming to t, what is the value of t? When the height of the water is 6.8 meters, what is the value of t? Because previously the first high tide occurred at 4:30 a.m. So we had taken the value of t as 9/2 because it was 4.5 hours after midnight. T value is number of hours after midnight. But now when is the first high tide occurring? It is occurring 50 minutes earlier. Previously it was occurring at 4:30. So now when is it occurring? Obviously 3:40, at 3:40 a.m., which is 50 minutes earlier to 4:30. So 3:40 a.m. is how many hours after midnight? That we have to find. That should be our t value. Okay. So 3:40 a.m. 3 is 3 hours. No problem about that part. 40 a.m. that means 40 minutes. So 40 minutes when converted to hours is 40 over 60, which is equal to 2 over 3 hours. Okay. 3 hours, and this is 2 over 3 hours. When added together, it is 3 and 2 over 3 hours. Converted to an improper fraction, it will be 3 times 3 is 9 plus 2, it is 11 over 3 hours. This is the value of t. Okay. So, in place of t, we will be writing 11 over 3 minus c plus 4.5. Okay. And now we will be doing exactly the same thing that we had done before. 6.8 minus 4.5 over 2.3, and we know the value of this part. This is equal to 1. I can write this as sine of pi by 2. This is equal to this part. Sine of pi by 6 times 11 over 3 minus c. Okay, and taking the arguments of the sine functions of both the sides, we get pi over 2 is equal to pi over 6 11 over 3 minus c. And I am cancelling the 2 pi's, means I am dividing the entire equation by pi, and then I can multiply the entire equation by 6 to get 11 over 3. I'm writing this part first. 11 over 3 minus c is equal to 6 over 2, which is equal to 3. So, c is equal to 11 over 3 minus 3, or this is equal to 11 over 3 minus 9 over 3. That is, therefore, c is equal to 2 over 3. Okay. So the equation will be h of t. It was h of t. Let me write as h1 of t is equal to 2.3 sine pi over 6 t minus 2 over 3 plus 4.5. Okay. So this is the equation of the water height for the Folkestone Harbor. The height is in meters. Okay. This is the suitable equation that we have found. Okay. So, students, we have completed answering question number 9, and I'm Nilanjana Sanyal. I'm an online IB Math A HL and IB Math A SL tutor. I tutor students from both within India and outside India, and currently I am solving the IB Math A HL past paper questions. In case you like my explanations, please do give this video a like, and please do share this video with your friends so that even they may get benefited by looking at these explanations. And please do subscribe to my YouTube channel. This will be motivating me to make more math videos for you. And please don't forget to press the bell icon so that you get notified as soon as I publish a new video. Okay. So thank you for staying with me till the end. We meet again very soon in our next session where I'll be solving question number 10 of the same paper. So till then, bye.